Okay, now we're going to take a look at how to translate words into algebraic expressions and or equations. This is useful when you're using mathematics to model something in the real world to help you solve some sort of problem. I'll tell you up front, the story problems in our textbook are contrived and don't seem very realistic, but the process involved is useful. And if you move forward in math and science and actually start to work with some more legitimate story problems, what we practice here will be useful. So um, we've been studying expressions and equations, and now we're going to just basically take that and apply it to when it's written out in words we need to translate, which is part of solving a story problem. All right, so this first example, let's represent the following with an algebraic expression. So no equations this time. So let's say we have something like a number decreased by 2. So that's written out in words. We want to change that to an algebraic expression. So a number, well, we don't know what the number is, so we're going to use a variable. I chose n. You could use another letter if you want. Decreased, so getting smaller, so that insinuates subtraction. And by 2, so how much smaller is it getting? Well, it's getting 2 smaller. So it'd be n minus 2. So n minus 2 algebraically represents what this says in words. Let's say we had um, let's say we had 5 more than 3 times a number. So again, we got words. We want to translate that to an algebraic expression. So 5 more than would be 5 on top of something else or added to something else. So 5 plus, and then 3 times a number. Well, again, we don't know what the number is, so I used a variable n, and we went 3 times that, so that'd be 3n. And we went 5 more than that, so it'd be 3n plus 5. 3n plus 5. Remember, addition is commutative, so you can write it in any order you want. Let's see. This next one, we've got the difference between a number and its square. So again, we don't know what the number is, so I have it as a variable n. Its square would just be that number squared, and we want the difference between a number and its square, so that would be subtraction. So the number is first, its square is second, we want the difference between them, so that'd be subtraction. So it'd be n minus n squared. Let's see, next we've got the sum, which hopefully we know by now is addition, of twice a number. We don't know the number, so I used n, and then twice that would be 2n, and 6. So I've got twice a number, 6, and I want the sum of those. So I add them together, so 2n plus 6. This last one for this example, we want twice the sum of a number and 6. So we want double something, and we want double of what? Well, we want double the sum of a number and 6. So again, we don't know the number, so I called it n, and we want the sum of that and 6. So it'd be n plus 6, and we want twice that or double that. So it'd be double whatever this ends up being. So we need parentheses, because I need to know what the number plus 6 is before I can do twice that. So I've got to do the addition first and then multiply by 2. So 2 times the quantity n plus 6. All right, so let's actually put some sort of real world situation with it and see what we get. So let's say we have someone named Anne and they're riding their bike at r miles an hour. And we've been asked to translate the following into an algebraic expression. So same thing we just did, except for now it means something. So let's say Anne's speed. We want to write an algebraic expression for Anne's speed if she bikes 5 miles an hour slower than what she was. Well, she was biking r miles an hour, and now she wants to go 5 miles an hour slower. Well, in order to go 5 miles an hour slower, she has to be going at least 5 miles an hour. So assuming she's already going 5 miles an hour or faster, then if she's going slower than that, it would just be her speed minus the 5 miles an hour. So we'll just take her speed minus 5, and that's how many miles an hour she's going. So for example, let's say she's going 7 miles an hour now, and she goes 5 miles an hour slower. It'd be 7 minus 5, which would be 2 miles per hour. That's how fast she'd be going. Well, what if she goes 3 miles an hour faster than what she currently is? So this is what she's currently going. She's going 3 miles an hour faster than that. So you add it to r, and that's how many miles an hour she's traveling on her bike, after she increases by 3 miles an hour. What if we want the average of her speed and someone else named Juan if Juan is going exactly 10 miles an hour. Well, we just want an average. So we take how fast she's going, which was R, plus how fast he was going, or she, I assume Juan's a he, and we want the average. So we add their two speeds together, divide by 2, and that'll give me the average. And then whatever that ends up being, that's how many miles an hour the average of Anne and Juan's speed is. So again, same thing we just did in the previous example, just now the variable had some meaning to it. All right, so at some point in math and science, you learned what's called uniform motion. So I'll just quickly remind you what that is. That's when something is moving at a constant rate. So, the car is always traveling 30 miles an hour, for example. And that was, the famous distance equals rate times time, or sometimes referred to as DIRT, where D is distance, R is rate, and T is time. And you just got to keep in mind that we want all the units to agree. So the distance and the rate, D and R, have to use the same units of length, and then the rate and time have to use the same units of time. So, they both need to use hours, they both need to use miles, for example, or whatever they happen to be, but there has to be some agreement in the units for this to simplify down and have some sort of meaning for us. All right, so let's look at one of those. Again, we're just practicing taking words and translating into algebraic expressions and equations. So let's say we have a helicopter that leaves mid-city, never heard of that, but we'll just go with it, at noon, and it flies east at 110 kilometers an hour. So if this is mid-city, this helicopter is going to fly east. So there's the helicopter. And it's flying at 110 kilometers an hour. 1 hour later, a plane left mid-city flying west at 320 kilometers an hour. So there's the plane, and it flew west. And wants to know how far apart are the aircraft X hours after noon. All right, well, we can figure that out. So let's see here. So let's start with the helicopter. So the helicopter, we want to know how far apart, that's distance. So we know that distance is rate times time because the helicopter and the plane are flying a constant 110 kilometers an hour or 320 kilometers an hour. So it's uniform motion. So for us, the distance would be its rate, which was 110 kilometers every 1 hour, times its time, which was X hours. And we do a little simplification. So the hours reduce, and we're left with 110x kilometers. So the helicopter has a distance of 110x. So that's how far apart, that's how far away from mid-city it would be. And the plane, let's see, the plane, its distance would be the rate, which is 320 kilometers every 1 hour, times, in this case, it left an hour later, so it would be x minus 1. So however many hours. So for example, let's say the helicopter had been flying for 3 hours. Well, since the plane left an hour later, it would only have flown for 2 hours because it's one less than it didn't fly for as long. So it'd be x minus 1 kilometers. And again, same simplification. The hours. Oops, this was hours later. And so the hours were, we'll simplify, and we'll be left with 320 x minus 1 kilometers. So that's this distance. So 320 x minus 1. And we want to know how far apart. So we want to know the total distance from the plane to the helicopter. So we're just going to add those two distances together. 320 x minus 1 plus 110x is going to end up giving us, let's see here, It'd be 320x plus 110x. So that'd be 430x minus 320. So it's that many kilometers. So that's how far apart they would be if you knew how many hours they had flown. So afternoon. So if it's been 5 hours afternoon, you could plug in 5 and simplify, and then you'll see how many kilometers apart the plane and the helicopter are. Okay. Not necessarily a uniform motion question, but just more practice with translating words, this time into an actual equation where we're going to want to solve something. So let's say a state legislature has 45 people. The number of men is 6 less than twice the number of women. How many women are there in the legislature? So again, you can choose your own variables. I'm going to let W be the number of women. And then the number of men is 6 less than twice the number of women. So twice the number of women, but 6 less than that. That would be the number of men. And I know that together the men and women make up the entire legislature. So we add those together and get 45. So W plus 2W minus 6 should equal 45. And that gives me an equation where if I solve a conditional equation, hopefully, where if I solve for W, I see how many women there are in this group. So if we combine like terms, add 6 to the other side, divide by 3, we see that there are 17 women. So algebra allowed us to quickly figure out how many women there were in a nice mechanical way. All right, so the last thing that we want to get some practice with, this isn't something we use a lot, but it can come in handy. Let's say you're dealing with a situation where there are consecutive integers. We're going to look at consecutive integers, consecutive even integers, and consecutive odd integers. So remember, integers are things like -7, +12, no fractions, no decimals, no radicals, nothing like that. Just positive and negative whole numbers and 0. So consecutive means right next to each other on the number line. So let's say you want to model consecutive, just regular integers. So the way we can do that is we can, again, I chose n. You can use another letter if you'd like. If we let n be any integer, so it could be any integer you can think of. In other words, n is an element of the integers. Then if you want consecutive integers, so if this is the integer you pick, then if you add 1 to it, you'll get the next integer on the number line. If you add 1 to that one, you get the next one, and you add another one. So, or you could subtract and go the other direction. I could subtract 1, and I'll get the integer to the left of n. I could subtract another 1 and get the integer left of this one. So it looks confusing, but if you actually pick an n, plug it in and see what happens, it kind of makes sense. So for example, let's let n be the integer +3. You could pick any other integer you want. Remember, n can be any integer. So I picked 3. So if you pick 3, then 3 is n. So 3 minus 1 would give you 2, 3 minus 2 would give you 1, 3 plus 1 would give you 4, 3 plus 2 would give you 5. So sure enough, 1, 2, 3, 4, 5, and so on, 6, 7, 8, 9, or if you go the other way, 0, -1, -2, those are consecutive integers. Those are integers that are right next to each other on the number line in a nice, neat order. But what if you want something more complicated, like even integers? So you want all the even integers that are next to each other on the number line. So again, let's let n be an element of the integers. So it could be any integer. Then if you want even ones, well, you can just take your n times 2, and that'll give you an even integer. And then if you add 2 to that, you'll get the next even integer. If you add another 2 to that, you get the next even integer. Or you can subtract 2 and go the other direction. Looks confusing, but if you pick an actual integer and plug it in, it makes sense. So I picked the integer negative 21. So if I plug negative 21 into our, don't really want to call it a formula, but it's kind of what it is. If I plug negative 21 in for n, then when I double that, I get negative 42, which is an integer. And then if I add 2 to that, I get negative 40, which is the next even integer as I work my way right on the number line. If I subtract 2, I get negative 44, which is the integer to the left of negative 42. If I subtract 4 from it, I get the one next to it, which is negative 46. And I can keep going in either direction. I'm only showing you a few. So this right here can get us consecutive even integers. And then what if we want odd integers? Well, it's going to be similar. We can let n be any integer. Again, you can pick anything you want. Then if you want odd integers, what you do is you just double whatever integer you pick, but you need to add one or subtract one from it to get an odd number. So if you add one, this will be odd. And then if you add 2 to that number, essentially you're adding 3 to whatever 2n is, you'll get the next odd number. Or you can subtract 2 from this odd number to get that odd number, subtract another 2 from this one, and you'll get that one. Again, it looks really confusing, but if you just pick an n, plug it in, and see how it works, it makes sense. So I picked the integer 6, and then I plugged it in. So if I take 2 times 6, that's 12, which is even. I don't want an even number, I want odd numbers. So I need to add 1 to it to get 13. But I can take that same thing and add 3 to it. So it'd be 2 times 6, which is 12. I don't want that. And I add 3, I get the next odd number, which would be 15. Or I can subtract 1 from 2 times 6, which would be 11. Or I can subtract 3 and get 9. Or I can subtract 5 and get 7. So it's just basically how do you adjust it to make sure that it's even or it's odd. So this is a little different than how the book explains it. The book I feel is a little bit more confusing. The way I've got this set up, you can always pick any integer you want. Makes no difference. Pick any integer you want, and then what I've shown you will give you consecutive integers, consecutive even integers, or consecutive odd integers, depending on what you want. All right, that's it.